Okay, we have one last slide here with some of these questions. Let me just move myself out of the way. So this is your standard textbook question of solve the equation. So to the nearest degree, which values of theta will satisfy each equation. And again, this part is in here. You must understand all this part is saying theta has to be between 0 and 360 degrees. So we're not allowed to solve for solutions where we're spinning around and around and around. And again, I think I mentioned before that's going to be covered in the next lesson, actually. So how do we solve questions like tan theta equals 1? The first thing you want to do with this kind of question is decide, is this something I can use special triangles for? Is this a special ratio? And it turns out it is, because one of our special triangles is this guy here, where we've got the 1, and the root 2. The other special triangle is the one where we've got a root 3 and a 1 and a 2. So what we need to do here is we need to just make sure that we're taking the easiest root, and special triangles generally make our life easier rather than harder. So what we can do is we can say theta reference is equal to, and we're looking up here, so 45 degrees corresponds with a 1, 1, 1, like opposite and adjacent. Remember, this is the same thing as saying 1 over 1, so opposite and adjacent. So reference angle 45 degrees is what you have. Now what we have to do is we have to go, okay, so we've got reference angle 45 degrees, but what quadrants is this in? And we look at this, and because this is a positive quantity, we can say this belongs in quadrant 1, and because it's tan, it's in quadrant 3. Remember that ASTC. If tan is positive, it's either here or here. So we know the reference angle is 45. The way I like to do this is I like to say, okay, in quadrant 1, theta equals, and it's really simple, quadrant 1, theta equals the reference angle. So it's 45 degrees. That's the solution. In quadrant 3, we'd say theta equals 180 plus the reference angle. So that would give us to 225. So if we push tan of 45 or tan of 225, it's going to be equal to 1. For B, sine theta equals 0.4. Is this a special triangle ratio? And there's nothing that has like a 0.4 or a 4 over 10. So this is not special. This is a calculator requiring question. So we must use the calculator here. So what we're going to do is we're going to solve for the reference angle by going inverse sine of 0.4. We're going to make sure, so I'm going to jump over here, I'm going to make sure that I'm in degree mode, and then I'm going to go second function sine of 0.4, and that gives me 23.57. Okay, I'm going to write 23.6 because that's good enough. So about 23.6 degrees. Okay. Then the idea is that's the reference angle. What quadrants is it in? We look at this again. We see this is positive, so this is in quadrants 1 and it's in quadrants 2. So in quadrant 1, theta equals theta reference. So it's 23.6 degrees. And in quadrant 2, we've got theta equals 180 minus the reference angle, because in quadrant 2 we're going all the way to 180 and then we're backing up by 23.6 degrees. So 180 minus 23.6, 180, let's see here, is this going to work? If we go 180, I should probably be able to do this in my head, but I'm halfway there, so let's do it here. 23.6. Okay, and then we got 156.4. So the other answer would be 156.4 degrees. Okay, those are my two answers. Oh, this says to the nearest degree. Okay, well, I guess that should have been 24 and 156. Not bad. Okay, so that's the process when you're solving any kind of trigonometry equation. You're trying to find the angle. It's a little more complicated now than just simply going inverse sine or inverse cosine, right? Back in grade 10, you always had, nice triangles, and the angles in the triangle were always less than 90 degrees. So we never had to worry about this quadrant thing. But now we're getting a little more complicated. And if you're wondering, what does this have to do with triangles? It still sort of has to do with triangles, but we're starting to think about more like moving around in full circles, full rotations, like all the way around. So we're talking about degrees that are bigger than 90. Trigonometry, by the way, is used for so much stuff. We're just starting to uncover it. Okay, this next one, cosine theta is equal to negative 2 over 3. So the thing you're going to want to do here is you're going to want to decide, is that a special angle, triangle, special ratio, however you want to say it. And it looks like it is, but it's definitely not, because there's a 2 and a root 3, not 2 over 3. So that's a calculator question again. So we're going to go inverse cosine to find the angle, and remember, do positive 2 over 3. So that's how we get the reference angle. So we're going to go over here, we're going to go inverse cosine, and then we're going to go negative 2 divided by 3. And I really like to close up that bracket just so it's all good. Oops. Okay, I just did the thing I said not to do. I said don't do negative. But that's what happens if I did negative. What happens if I do positive? So now I'm just going to go 2 divided by 3. Let's just see the difference here. Okay, so you can actually tell, and this is maybe worth me making that mistake. If you do negative, you get 131.8. If you do positive, you get 48. Which one is actually your reference angle? And your reference angle is 48.19, or whatever you want to call it, okay? That is your reference angle. Your 131.8 is actually the quadrant 2 angle. So again, if you start putting in those negative signs, you're going to confuse your calculator. Reference angles have to be less than 90 degrees. So we got to make sure we're getting something less than 90. So then what we say is we look at this and we say cosine is negative 2 over 3. So when is the cosine ratio negative? And that happens in quadrants 2 and 3. So in quadrant 2, the angle is 180 minus the reference angle. So 180 minus 48.2. It's got to be what, like 131.8, I think. So that's about 132. And then in quadrant 3, theta is equal to 180 plus the reference angle. So that's 180 plus that, which is 228.2 degrees. So about 228 degrees. And if you want to check your work, you can always go to the calculator there. I seem to have a hard time talking right now, but you can always go cosine of 132, and we push equals. And it didn't give me exactly 2 over 3, but very close because I did some rounding. It's negative 0.66, which is basically 2/3, okay? So we can check our work that way. Okay, finally the last question, sine theta equals negative 1. Is this a special angle? And it turns out it is. So you can imagine a situation where you've got a triangle where your ratio of opposite over hypotenuse is equal to 1. So that's where your opposite and hypotenuse are the same. But what quadrant is that in? This is the tricky one. So what we want to do is we want to go up to our little Cartesian coordinate system, and we want to think about where is the ratio of opposite over hypotenuse equal to negative 1? Or, in other words, the opposite is negative and the hypotenuse is positive. The hypotenuse is positive everywhere, but where are they the same length? One of the options is when it's pointing straight up at 90 degrees. Then the opposite is positive and the hypotenuse is positive, and that's not what we're looking for. When it's at negative, when it's pointing downward at 270, we've got the opposite being negative, and of course by definition the hypotenuse is still positive. There is no way of really nailing this question so much as you've got to think about this Cartesian coordinate system, and you just kind of get a bit of experience with these things so you know, but you've got to try and draw it out, and this is usually the one that causes people to trip up. So we're not going to do reference angles or any crazy stuff. We're simply going to say theta equals 270 degrees. That's the only possibility here. Now, just for fun, let's go to the calculator and let's go inverse sine of -1 and just see what happens. We get -90. Okay, and if we go to inverse sine, now I keep saying don't put in the negative sign when you're doing reference angles, so we'll make a +1 and we'll get a reference angle of 90. So what your calculator thinks you want is it thinks you want this up here, that angle in there, and your calculator unfortunately just is not programmed to give you the correct response, so you have to be a little smarter than your calculator. Anyway, there we go. Those are some different styles here. Hope that is helpful. See you on the next one.